Hello everybody, good morning, good afternoon, depending on where you are, good evening. Welcome to our webinar today. Today we have Susan Stolley with us, and she will be talking about Speech Intelligibility Index, what it is and what it's good for. My name is Mariana, and I'm here just to help out, and if you have any problems or anything, you can write to me, and then I will be able to help you on the way. This webinar will be recorded, and even though we wrote that it was a half an hour webinar, actually we have an hour webinar today. There has been a misunderstanding. So, but if people can't stay the whole hour, then we will record it, and then you will be able to see later on. A little bit of tips and tricks. So all participants are muted to reduce background noise. You can ask questions. If you want to ask questions, you can see on the right side of your screen there is a question box. You can write the question box. You can write your question in the question box, and we will see how many of the questions we can answer today. If we are not able to answer all the questions during the webinar, then we will send you the answer later on. Yeah. Then I will hand it out to Susan. And welcome, Susan. I'm really happy that you give the time to give this talk for us today.
Okay. Thanks, Mariana. Thanks for the invitation. Hello, everyone. And we're just going to take a little bit of time today to go through the Speech Intelligibility Index, background information on it, and clinical applications that we can use with this tool that's available to us through our verification systems. So I'm just going to place it in a little bit of context with thinking about what is it that we think we want to achieve more generally with providing hearing aids with people. We want to do things like provide high-quality fittings that are provided early. We want consistency of fitting and fitting benefit across our patients. And for children, we want fittings that parents can understand and that teachers can understand. And there are places where we can pull the SII tool in to help us with some of these goals, and places where it shows up also in the research literature as being important in certain ways. So we're going to go through a few things about how it is calculated and how we want to use it. One of the reasons why people are becoming more interested in this tool is that there's been a recent large set of studies looking at long-term outcomes for children with hearing loss, and this graph that I'm showing you here may seem a little confusing right now, but what we're going to do today is we're going to break down a few things that underlie that and come back to it later on in the presentation. From these studies, we know that not all children are currently receiving consistent audibility from their hearing aids, and that the only known way to fix that problem is to routinely verify all children's hearing aids with a probe mic system to ensure that the appropriate amount of speech audibility has been provided. I'm familiar with this study on children. I'm sure we would see the same thing if we looked at a large-scale study of adults. The graph that you're seeing here is graphing for you aided speech intelligibility index values. But if you're not familiar with what those mean, you might be thinking to yourself some of the questions that you see in the bubble here. What do those mean? What are they telling me? And how can I use them? If you're not sure what those numbers mean, then you've come to the right seminar today. We're going to talk about that. So first, let's talk about when we would make a measurement of the speech intelligibility index in the context of a hearing aid fitting. When does it show up? So in the steps of going through the process of giving someone hearing aids, we're going to start with audiometry. If necessary, if we're fitting a BTE, we would make an ear mold impression and order an ear mold. We might make RACD measurements, and then we might move on to doing the hearing aid fitting with fine-tuning and verification with a real ear system. The aided SII actually comes from that third step, and it comes automatically, where if you've invested in a probe mic system that lets you measure the hearing aid's response for speech, many of those systems now will automatically calculate for you an aided speech intelligibility index. You don't have to do any extra work to get that. It's an automatic display that comes from that measurement that's provided to you automatically. And we'll just review that making things more accurate specifically for children includes things like prioritizing insert phone audiometry so that we get ear-specific information from young children. That's considered a best practice. We would make ear molds of soft materials that fit the young child's ear. We would let the software system know that we've used an ear mold as part of the fitting. We would make a measurement of the reeler to coupler difference. There's a link on the bottom right here for a step-by-step procedure for doing that with this particular system. If that's not something that you are familiar with, there's more information outside of this seminar there for you. The next step would be that we would verify the hearing aid. We would see what are the levels of aided speech that are coming out of that hearing aid and how do those compare to a prescriptive target. Is it giving us the right level? Is it giving us the right shape? Have we smoothly fitted the response of the hearing aid to the target? And when we've made that measurement, we've actually already gathered all of the information that we need to calculate the speech intelligibility index as well, because it's calculated from measures of amplified speech. So after we've done fine-tuning and verifying the hearing aid with our hearing aid analyzer, we can go ahead and add that information. So I'll show you in a moment where to find that information, but let's figure out what the SII means and what it's going to tell us before we go interpreting some case examples that I'll show in a few moments. Just the background information on where this comes from. The SII is, the full name for that is the Speech Intelligibility Index, and it has its roots in the older articulation index that many people learned about in their original training in school when they were learning about hearing aids and hearing aid fittings. Some people might be more familiar with the articulation index or AI terminology. Really, these two indices are the same thing. They began in the Bell telephone labs in the 20s to 40s when people were trying to figure out how to get telephones working. And as you know, that had links to the development of early hearing aids, because once they figured out how to transmit a speech signal electronically for the purposes of telephones, they were also able to harness that for the purposes of early development of hearing aids. So really, anytime we're trying to take speech and send it through a system, we might want some measurements of how successfully that speech was conveyed. And at the time that they were first working on this, one of the things that this helped with was that prior to that, the only way that they had to evaluate the success of whether the speech was transmitted across a prototype telephone system was they tested it using people. They did what we would call today outcome measures. They would spend hours and hours saying words over the phone and having another group of people listen to those words as transmitted and scoring them. And that final score would be what would be the measure of whether or not that particular prototype system was a good one or a bad one. So it's sort of a lot like the early methods for fitting hearing aids, where testing of the person was the way that the hearing aid was chosen. And we know that we have better and more technically accurate options these days. So back then, the AI was proposed as a time-saving electroacoustic alternative if what your goal was saying how much of speech has been transmitted through this system. And so even today, we still want to maybe know that about our hearing aid fittings. So another thing that might be familiar is you might have learned about the Count the Dots AI. So this is an older tool from 1990 that was developed by Mueller and Killian and was popular as a counseling tool and often included in teaching programs for a long time. And on this, you would plot the person's audiogram, and then you would count the number of dots that were above threshold. And the number of dots out of 100 was the percentage of speech that was audible. So you see the shaded speech banana region, you see the higher concentration of dots in the 1 to 4,000 hertz regions, indicating that there's more importance of speech in that area. And it was an easy tool that people could use to estimate how much speech was audible without hearing aids based on just thresholds. So that's a nice counseling tool and a popular way to explain the basic concepts of the AI, or now, as it's now called, the SII, and many people wish to have a good way to apply something like that for hearing aid fittings. Putting the aided thresholds on there was a common strategy. Electroacoustically, that's kind of a problem when we're dealing with compression hearing aids that do different things for soft speech than they do for mid-level speech and loud speech. Aided thresholds don't do a good job of accounting for that. So many people wanted a better way of having something like this, but for hearing aid fittings. More recently, the term articulation index was replaced with the term speech intelligibility index. This arose following a restandardization of it from ANSI in 1997. And this newer version, it's the same basic set of concepts. It's just it was felt that the term speech intelligibility was a better reflection of what the index is really all about, as opposed to articulation, which people more associate with how someone is pronouncing their words. And that's not really what this measures. So they renamed it, but it's the same index that you may have been familiar with already. And it is commonly available in hearing aid test equipment, and it is a simplified and standardized version of that original Bell Labs model. Put simply, the SII is a number that is out of 1, so a 0.5 would be half of 1. So that's also sometimes expressed as a percentage, so 50%. So it either is out of 1 if you're doing proportions or out of 100 if you're doing percentages, but it's the same concept either way. And this is going to summarize the proportion of the speech energy that is audible to the listener and that is also above any kind of background noise or reverberation. So it's what amount of speech is available to you. It's an audibility sort of a measurement. So because there were a few little changes within the restandardization and renaming of the AI to the SII, Killian and Mueller updated their count the dots method accordingly, and this is an updated one. So if you like using the older count the dots form, I'll just share with you that there is a link to this freely available article that has an updated version of it in 2010 that's surprisingly accurate for unaided speech situations. The energy range and shape is still based on the shape of the speech envelope, and you still see more dots in the mid-frequency region to reflect the greater importance of speech in that area. So with this tool, you can plot the person's unaided thresholds on there, count the dots that are audible, count the dots that are inaudible, count those up out of 100, and this is an effective counseling tool for explaining to people what type of speech signals are available to them and not available to them with hearing loss. So this is useful when we're trying to explain concepts around hearing being frequency specific, because often the consumer doesn't necessarily know that just making things louder doesn't necessarily deal with all of the effects of hearing loss. If we've got high frequency hearing loss, sometimes making things louder doesn't necessarily deal with that. What we really need is the more shaped amplification that is provided with a hearing aid, and this type of tool can be an effective illustration of that type of conversation. So it's often used as a counseling tool for that type of reason. Again, it's not from a hearing aid analysis though, so can we take this further and can we try to have a tool that speaks to what is the hearing aid doing to the speech signal? So we can do that through technical measurements. So I'm just going to go through and conceptually illustrate a few of the things that are taken into account when the SII gets calculated. These are the background calculations that you don't have to do manually. They're going to be embedded for you in the background of your hearing aid analyzer. So the SII standard has a set of rules and steps for calculating the SII, and essentially what they're going to do is sum up the audible energy that is available to the person. So the green area that you see here is a representation of unaided speech. So we know that speech has more energy in the low frequencies. This one is peaking at about 500 hertz, and then it rolls off gradually in the high frequencies, and it has about a 30 dB dynamic range. So that's the green area that you see. That's speech when we look at it in dB, sound pressure level, unaided. Now, if somebody has normal hearing, they probably can hear all of that green area, and the calculated SII is going to be close to about 100%. However, what if somebody has a significant hearing loss? The gray area that's shown here are the threshold levels of someone that has about a moderate hearing loss that's sloping off in the high frequencies. And you can see that now only a little bit of that speech is peaking up above threshold. Only the low frequency parts of speech are audible for that person unless the talker raises their voice. So that low frequency peak at 500 hertz is audible, and some of the mid frequencies to about 2000 hertz are audible, but with the roll off of the high frequencies of unaided speech, only a little bit of it, I'm going to ballpark it at about 30% or so, is above threshold. So the SII calculations are going to call that at a percentage and give you a percentage value. That number comes from a few different calculations that are embedded within the standard. One of it is summing up the energy that we see here, but there's also several set of considerations that it uses. one of the things that we know is that if we take a hearing aid and add that to the speech signal, add the gain of the hearing aid, we're going to be able to amplify the speech and shape it to make it be louder, give it a little bit more high frequency emphasis, and that's going to cause much more of that green area to become above threshold. And in this case, maybe the SII value would go up to something like 65–70% with this particular hearing aid fitting. So as we adjust the hearing aid, we might see the aided speech intelligibility index numbers changing as we provide more and less aided speech audibility as well. So that we should expect things like a difference between unaided and aided values for the SII, and we can expect that different hearing aid fittings might also have different SII values. In hearing aid systems, the audibility, the summing up of the screen area that I talked about, is calculated following a standardized method. And one of the things that happens is that the sensation level of the peaks of speech is calculated as a proportion out of 30. So the basis of the number is really those peaks of speech. So if you're used to showing something like percentiles on your fitting screen so that you can see speech peaks, those speech peaks are an important part of this number. So it's not where the long-term average speech spectrum is, it's where the peaks of speech are that's really driving this number. And the maximum number that the sensation level can be at any frequency is going to be 30. As soon as you hit 30 at any one frequency, you've reached 100% of the audibility that will be counted at that frequency, and you can't go higher than that. So on this illustration that you see to your right, the arrow that's near about 1,000 hertz is giving the full 30 dB of speech audibility at the speech peaks. In contrast, the one over to the right of it that's at about 3,000 hertz or so, it's giving more than 30 dB of audibility, isn't it? That the arrow that we could draw between thresholds and the peaks of speech is actually more than 30 decibels. But you're only going to get credit for the top 30. Above 30, there's no more credit given for audibility, so there's no additional SII benefit going louder than 30 dB of audibility. So that's important to understand just when maybe we have an area that's really quite audible in one part of the hearing aid fitting, like maybe a big peak in the hearing aid fitting, yet your value is not close to 100%. It might be this background rule that's causing some limitation in the value. We often, with hearing aid fittings, don't see full 100% speech audibility, and there's a few different reasons for that. This is one of them. There's also other things that come into the number that are done behind the scenes. One is that there are built-in corrections that are included for upward spread of masking. So if there is any kind of a background noise built into the system, that can be included, and also just upward spread of masking from within the speech signal itself is included. And both of those things can actually bring the SII value down a little bit because a masker takes away audibility by masking it. So that's another reason why sometimes the SII values are not really 100% for some of our fittings. Another variable to know about that's a behind-the-scenes variable with this number is that the mid-frequencies in any SII value are almost always weighted to be more important than the low frequencies or the high frequencies. The exact shape of it, as you see illustrated here, can vary according to the type of speech stimuli that you're using. So on the x-axis here we've got frequency, and on the y-axis we have a number out of 0.1 that says how important is that going to be considered. And there's an average speech one shown in the bright green bars that's often used, and it's just an average across a number of different types of speech tests, and compared against critical band spacing that says on average speech probably has this kind of importance function. The area between 1,000 and 4,000 hertz have the highest green bars, meaning they carry the most importance of the speech signal, and then the importance rolls off above that in the high frequencies and also more gradually rolls off below that in the low frequencies. So what that's going to do is give more credit to audibility in the mid-frequency area between 1,000 and 4,000 hertz, and it's not going to credit as much audibility that's provided in the very low frequency and the very high frequency region. You see that there's a couple of other speech test importance functions that I've shown for comparison, the CID22 list and the NU6. They're similar but slightly different. So there's you can tailor this to the type of speech stimuli that you're using. That type of tailoring is really usually more done in research studies. In clinical measurements of hearing aid verification, typically what we're seeing is that average speech one that is, you know, fairly appropriate to use for most types of speech materials. It's the average speech one that's going to be built in behind the scenes when we're using an aided SII from a hearing aid verification system. The reason why this is important is that that weighted audibility is going to get added up across frequencies, and sometimes what that means is that your audibility doesn't actually get much credit, or it might get no credit at all. So in this particular example, the weighting function for nonsense syllables is 0 at 200 hertz. So even though there's some nice audibility happening, 47% audibility at 200 hertz, it gets multiplied by 0% importance and functionally becomes as though there is 0 audibility at this particular frequency. So that is one of the reasons why sometimes we see nice audibility on our fitting screen, but the SII value is a little bit lower than we might expect. So these are all just, again, background variables that have to do with how the SII was designed, and it was designed to take into account speech importance. And so audibility at the low and the high frequencies might not get as much credit as you might expect it to do when you're looking at the fitting itself. Both are important, though. This is not an argument to not provide low and high frequency audibility. It just explains why the SII might not agree with what your eye is telling you on your fitting screen. Okay, so let's just work through a couple of little examples. In this example, what we're looking at in sound pressure level is normal hearing, listening to unaided speech at 65 dB SPL. There's no masker in the background. And I've used an average speech importance function shown by the green bars on the top right. So on the left-hand side, this is a graph showing the thresholds as the circles. We've got frequencies going from low frequencies to high frequencies from left to right. And we've got levels going from very soft levels at the bottom of the graph to very loud levels at the top of the graph. The circles are the thresholds. The green lines are the speech spectrum, and the peaks and valleys of speech are percentiles of speech. And you can see that all of the speech really is above threshold except for a little tiny bit just below 10,000 hertz. The SII would see all of that audibility as full audibility, and then it would weight it by the band importance function, and in this case it would sum up to an SII of 100%. So it's saying all of this audibility is available to this listener. So that's a really simple example. If we change that up and just say, instead of a normal hearing listener, let's take a flat 50 dB hearing level audiogram. Converted to SPL, it's not flat anymore, so that's why the circles that you see there are not flat at 50, because this is being shown in SPL, not HL. And in that view, we see a little tiny bit of audibility at the peaks of speech in about the 600, 700 hertz region, and another little peak at about 1,000 hertz and above. Just those little tiny bits are being counted as audibility by the white bars on your right-hand screen, and then weighted by the green band importance function. We're left with very little. We're left with only 4% SII. So this type of very limited and unaided audibility for someone who's a hearing aid candidate is going to be reflected in the SII value, which is going to be low. So these two examples generally agree with what we're seeing. We're seeing very little audibility in this example. We're seeing very full audibility in that example. We're getting 100% audibility from the SII here and only 4% here. So we can begin to interpret the number and say, okay, well, what would that look like with a hearing aid in the mix? And we would expect the 4% number for here to increase to a more acceptable number with a good hearing aid fitting in the picture. So the SII is a summary measure that gives a summary of the amount of speech that is audible to the listener, taking into account some masking effects and the importance of different speech regions, and it can be calculated for either unaided or aided speech. As you've seen, though, it's really just looking at the electroacoustics of the situation. It's not looking at the person or their brain or what they understand or anything like that. It does not predict the speech recognition score. You could have an SII of 100% and a baby who is 1 day old who hasn't learned how to recognize speech yet, and they're not going to get 100% speech recognition. So the person is what drives speech recognition scores, not the SII. We'll talk a little bit more about that at the end of the presentation. So our third topic for today is where can I find it? So now that we understand what the SII is really all about, what it tells us and what it doesn't tell us, we'd like to know where we can find that on our fitting screen so we can begin to make use of it. So I thought I would just show a quick video of what type of fitting measurement I'm talking about making. So on this particular example, we're on the aided response screen. On the right, you see a hearing aid being verified, and the percentiles analysis of speech is shown. Here's the maximum output. And after you've done a test like this, down at the bottom right area of the screen, there you can see a purple area and a red area. I'm going to zoom in on those in a minute, but it's down there where the SII values are reported for you. So let's zoom in on that. This is that fitting, and the purple and red areas that I mentioned. So the purple test was done with speech at 65 dB, and it has a calculated SII of 38%. The red was a measurement of the maximum output of the hearing aid using pure tone sweep at 85. That is not a speech signal. And so for the red test, the SII value says NA, not applicable, because there is no such thing as an SII for pure tones, because it's really a speech intelligibility index. So any speech test is going to give you this value, and the non-speech signals will not, and that's appropriate. So it's calculated automatically for you. You don't have to click on anything extra to get it, and it's reported for you for each speech test that you run. In this particular example, it's 38% audible. So where that's coming from is that although we're close to target at some frequencies, there's some high frequencies, so look at around 4,000 hertz, for example. That's below threshold, so we're losing some audibility there. We're also losing some audibility of the bottom bit of the 30 dB range of speech, so the bottom percentile area, the lower limit of the light purple area, some of that is falling below threshold. So we've got some inaudibility happening that's taking the SII value to be less than 1,000 or less than 100%. And there's also the importance weighting, there's also the upward spread of masking, and those sorts of corrections as well that will bring it down a little bit further. So the one question is whether or not that's a good value for this particular fitting or not. So here's a different example. Would you judge the fit to targets acceptable for this particular fitting, and would you expect to see a high SII value? Looking at the purple fitting, would you expect it to be a good value, a nice high value? So the fit to targets that we can look at would compare the heavy dashed purple line to the solid thinner purple line and look at the agreement between those two. Judging those, we've got pretty close fit to targets through to about 4,000 hertz, and the SII value is in fact higher than the previous example. Here we're looking at an SII of 64%. So we've got more of the speech audible across the bandwidth of the hearing aid fitting, and we have more of those valley speech, the bottom percentile of the purple light area, making it closer to threshold or above threshold. So there's a little bit more audibility visually on this example compared to this one. And this one has only 38% SII, and this one has 64% SII. So there's, again, this agreement between what we see that the fitting looks like and what the SII value is reporting to us as a summary value from that. So here's another example. Would you expect the aided SII to change with input level? So as we take speech from being soft to mid-level to loud, the overall level of that speech is going to increase on the unaided side and also on the aided side. And so we are probably going to get more audibility for loud speech than for soft. And here we've got 3 measures of the speech signal being tested for speech at 55 on test 1, 65 on test 2, and 75 on test 3. And you see the SII values increase from only 51% up to 70% as you go from soft through moderate through loud speech. So those are some nice summary numbers that can be used to explain in a simple way the importance of speech input level. and how soft or distant speech might be more challenging for someone to hear, even though they're wearing a hearing aid. And these percentage values can be used as ways to explain some of those concepts as well. Okay, so let's talk a little bit about interpretation. We're going to work through some of the ways that we can connect what the SAI means to normative studies that have been done in the literature, and also connecting it to predictions of how people understand speech signals and the kinds of counseling messages that we can use to make better use of having the SAI in our system. Okay, so I'm going to break that down into 3 different clinical applications. Application 1 is looking at the percentage of speech that is audible, aided versus unaided, and using that as a counseling tool. Application 2 is whether the percentage of speech is typical of fitting for that degree of hearing loss. And application 3 is whether or not the SII can be used to predict speech recognition. Okay, so first of all, what if you wanted to make the following statement to someone who does not yet have a hearing aid, or you want to illustrate the difference between unaided and aided? For example, you're trying to explain what the impact of the hearing aid fitting is to a parent, to a teacher, to a speech language pathologist, or to a spouse. So someone who's not technically trained in hearing aid fitting, and for whom the wiggly lines that we look at on the graphs might be a bit daunting. One of the really nice things about the SII is that it's in a percentage, and people understand percentages. So here's just a photo of how I took this measurement. So you see on your left, this is done with the reference microphone at the coupler microphone and just running unaided speech as a measurement. That lets me get the SII value. And that's the orange curve and the orange set of measurements that you see here. So for this particular sloping loss, the speech is only 24% available to that person. So the SII is 24%. And the reason why I'm showing you the picture on the left is that what I find sometimes happens is that when we're teaching our students how to use systems, they sometimes forget to take the coupler off of the coupler microphone if they want to make a measurement of unaided speech. And if you leave the coupler on, it's going to actually roll off the high frequencies even more, because the speech has to pass through the coupler as well. So if you actually want this number and you want it to be accurate, a good idea is to take the coupler off and just put the reference microphone to the coupler mic, and then you've got a good measurement of unaided speech. So at that point, you can use this to explain how much of unaided speech is audible, and then you'd be able to compare that at a later stage of the fitting process to the aided speech and show that it changed, and use that as counseling information. So if as a parent, I know that my child only can hear 24% of speech without her hearing aids, and that increases to 75% with the hearing aids, maybe that's a number that I can really make use of and understand, and understand that that's probably an impactful change. So that's an example of using it in a counseling way to explain the impact of unaided speech listening versus aided. Another thing that comes up sometimes and came up frequently when we first started making routine use of the SII is that because not all of these numbers are 100%, any number that's less than 100% sometimes needs a little bit of explaining. So what we know is that it's normal for the SII to vary with degree of hearing loss, and that hearing aids that are fitted to within 5 dB of target typically fall within the range that you see shown here. So this is a score sheet that we use in our clinic, and it's available for free download from the link that you see on your left. And the way it works is this. So the pure tone average is along the x-axis. So you look at the ear that you're fitting and you calculate the pure tone average, and you find that. And then on the y-axis, you would pull the aided SII value from your verification system. So in this case, it's for 65 dB speech that I'm going to show you. In the downloadable tool, you can get 65 or 55. So let's just work through a specific example. So here's that fitting that we did a few minutes ago that gave us 64% of speech audibility. The SII value is shown in the red circle here. And then we can look at the pure tone average, which for this particular fitting was about 60, and the aided SII is about 64, so that would be plotted here. And that falls within the typical range for well-fitted hearing aids. So although it's not 100%, it is a typical amount of speech audibility for well-fitted hearing aids for this child's degree of hearing loss. So that's a fair statement based on those normative data. These are from large-scale norms collected across a large number of clinics and are available in publications. The reason why we care to do this, make this statement about the speech audibility being typical for well-fitted hearing aids for this child's degree of hearing loss, is that if we look at this recent paper, this is the graph that I showed you way back at the beginning of this talk, from the Outcomes for Children with Hearing Loss study, they're plotting their aided SIIs from a large number of children, and they're showing you the ones that are in the solid black lines are the ones that were well fitted to targets, so they're really closely fitted to targets. You can see that they're all falling in the top of that range. They're falling in a good part of that range. The ones that were fitted well outside of target, which were often underfitted, as you can see here, are shown in the open symbols. And they are falling below the range or in the bottom part of the range. And it's those children that were more at risk for poor long-term speech and language development outcomes when they were followed up for a long time. This variable that we're looking at right here, this aided SII and whether it's a good value, showed up as a predictor of long-term outcome for children who have hearing loss because it's indexing whether or not the speech audibility was being provided in a way that gives full access to speech, right? If you have a good fit to targets, you have a good SII for that degree of hearing loss, and you've removed a barrier to long-term speech and language development outcome. The other barriers and facilitators that they found in this study were things like regular hearing aid use and quality of language provided to the child. Those are just as important. But right now, zooming in on just the hearing aid fitting, if we're trying to do a good job there, one of the things that we can do is make sure that we've got a good fit to targets and use that SII value to say, is that a good SII and does the parent understand the percentage of speech that's available with versus without hearing aids. Okay. Another clinical application that we sometimes want to be able to do, this would be if you wanted to be able to say this amount of aided SII should result in a score of 85% correct or something for whatever speech test you think you want to use. So this gets into transfer functions, and you may have learned about these in school called performance intelligibility functions, and basically they're always taken from norms for a specific test. So if somebody tests a whole bunch of people on some particular aided speech test and they know what their SII values are, and then they log whatever the percent corrects are across their project, they might be able to fit a curved line to that to say, this is the normal amount of percent correct we would expect from this test for this type of patient from that amount of SII. So really this is an issue of norming. It needs to be taken from normative data. So I'm going to just show you a couple examples of why that matters and how it matters for different people in the literature. We know from studies in the literature that this type of transfer function is always dependent on a whole bunch of different factors of the speech material. So easy materials are going to have a steeper function than harder ones. Children are not the same as adults, and people who have hearing loss might have a more shallow function depending on their hearing status, the quality of their amplification, whether they've got visual cues, and their cognitive status. So there's a whole bunch of variables that go into predicting a speech score from an SII value. You actually have to know a fair bit to be able to do that. Here's one example of a data set that I collected a long time ago looking at just the impact of age on nonsense syllable recognition. So I measured the SIIs, so you can see those along the x-axis from really low values to really high values, where more SII certainly was associated with better scores. Everybody's scores are going up as they're given more SII. The percent correct scores are scored from 0 to 1, that really meaning 0 to 100%. And the adults are shown in a solid thin line. These are all people who have normal hearing on this particular graph. So adults are able to do quite well with only a very low SII value. And then the younger and younger that the children were, the more SII they needed to hit the same score as an adult would. So children need more audibility than adults. We know that from lots of different studies, not just this one. And one way to look at that is that if you have an SII of 0.4 on this graph, that's the same as a clinical SII of 40% from your measurement system. An adult would get above 90% correct with that score. A 7 to 9-year-old would only get about 65% correct. So we know we need to give children accessible speech and time to develop. And in terms of interpreting the SII for clinical applications, this is an important thing to bear in mind, is that 40% might be lots of SII for an adult. It is not for a young child. They need more audibility than what an adult would need. This has also been shown for older adults. So a really classic paper that's, if you're interested in SII stuff, is Sherbako and Studebaker in 2003, where they looked at a large number of adults who had normal hearing, and on your left, and then the graph on the right shows you older adults who have hearing loss compared to the normal hearing range, where you see that some people who are using hearing aids or listening to amplified speech are falling within the normal range, and some people are falling below the normal range. And in this article, they started to look at who is that and why are some people falling below the normal range while other people are doing really well. They've all got similar amounts of hearing loss. And what they actually wound up pulling out of this data was an age correction showing that you know, very elderly adults are not hitting the same kind of percent correct score with the same SII value as a younger adult would. So they actually had an age effect at the older end of the age range. So on the previous slide, I'm showing you an age effect at the younger end of the age range, and in this study, they wound up looking at an age effect on the older end of the age range, particularly above about age 75. So there are these cognitive and developmental and age-related effects that go into predicting a speech score. Remember that the number that your verification system is giving you is a raw measure of aided speech audibility, really. Even though it's called the Speech Intelligibility Index, it's really driven by audibility more so. And predicting an individual person's speech intelligibility from their hearing aid is challenging, and that kind of speaks to maybe running outcome measures and seeing what that individual person actually is getting functionally from their hearing aid fitting rather than trying to predict it in many cases. The other thing to bear in mind in terms of limitations with this tool is that mid-frequency importance weighting that we looked at earlier today does have a few side effects. It renders the SII as being not very sensitive to the bandwidth of fittings. You can have two fittings that vary just in their bandwidth and have similar mid-frequency audibility, and the SII values are going to look pretty similar. We know that broadband fittings are a good idea and that they're important for providing access to S and other high-frequency sounds. The SII, however, is a summary measure and doesn't really speak to this important fitting issue. There was a nice study by Sam Gustafson and Andrea Pittman that looked carefully at that and showed that you can have a good SII value from bandwidth, or you can have a good SII value from mid-frequency audibility, and those two things don't necessarily pan out in quite the same way in terms of benefit, because they're providing really different access to the speech cues. So remember to keep an eye on bandwidth and not look at SII all by itself. It's one tool in our toolbox. It's not necessarily meant to be used in isolation. So the best SII really does start with a good fit to targets, and I think we wind up here using it more as a counseling tool and a little bit less as a fitting tool. It's a nice bridge between verification and counseling, and that's kind of how we're making use of it these days. So we'll just do a quick summary and then see if we've got some questions. So just think about if there's anything else that maybe we want to talk about again or that I didn't make fully clear the first time around. So while you're thinking about that, in summary, here's some basics. The SII is an automatically computed and standardized summary number. It does not optimize the fit to targets or the audible bandwidth of the hearing aid, because that's your job. It does, however, help non-fitters by providing a really easy to consume percentage value that summarizes that fitting, and it can illustrate the difference between unaided and aided speech access in a really effective way. We know that lower than typical SII values may be a red flag, that the fitting may need to be re-examined in terms of whether it's providing enough benefit, and recent research from children tells us that this is an important part of long-term outcomes for them. So for Monday morning, if you didn't know the SII value was there or you didn't know how to interpret it, just keep an eye out for it and maybe see if you want to start pulling it into your practice. Your system does provide that for you automatically. and you can remember to just keep on verifying. It is a major key to consistent success and one of the most important things we can do to ensure benefit for the patients whom we serve with hearing aid fittings. So I'll say thank you very much for your attention today, and turn it over to the audience for any questions or comments that you might want to provide. Thanks again for the opportunity to my colleagues at GN, and have a lovely day if I don't hear from you any further.
Thank you, Susan. Thank you very much. If you want to write questions, you can write in the box on the side. Susan, I would like to ask you one thing. If we go back to the example that you had, the fitting example, you had two fitting examples, the second one. Can you go back to that?
Yep. This was the second one, yep.
No, the first one then, the other one. Sorry. Yes, okay. This one, exactly, this one. Here, if you look at the hearing thresholds and you look at the target, and even if you could match the target, I think you can't match the target here, probably because of the hearing aid in the high frequencies can't get that high. But if even if you could get that high, you will not get 100% SII, right? Because you are below the thresholds.
Okay, so where we're really not meeting thresholds is up here.
Yeah.
I just found where your highlighter was. I really wanted that while I was talking before. So we're losing some audibility here. All of this is not audible, right?
Yeah.
So all of that is not audible.
Yeah.
That's where we're losing most of it. That's a large part of why it's only 38%. If we could get some of this amplified up here in the high frequencies, then that certainly would improve things. But like you said, it's probably the bandwidth limitations of the hearing aid. I wanted to pull in a real example so that it illustrates what we really face when we're pulling some of these numbers. So yeah, anytime we can extend the bandwidth and get more audibility, that's going to improve things a little bit. We're also losing some from the valleys of speech for sure. But this may be a typical value for this degree of hearing loss, and that's what plotting it on the score sheet tells you, right? So I think we might be very interested in knowing if this particular one fell into the typical fit zone of the score sheet to say whether that's typical for that degree of hearing loss. It's also going to go up a little bit if we go to a higher speech level. This one is only 65, and certainly if we bump things up a little bit, that will pick up some of those valleys of speech area that's inaudible down here. And there was something else you asked me that I lost track of. What was it?
And that's one of the questions that I always get, that the target here, it's below the hearing thresholds.
Oh, the target is below the thresholds. Yes. Yeah. Yeah, it is. Let me just see if I can get a different tool here. Okay, so the target is below thresholds here, right?
Yeah.
And the hearing aid fitting, though, is all the way down here. So it's not close to fitting that target. If you were able to take this area, the long-term average speech spectrum, and actually fit it to that target, some of those speech peaks would be up here, and you would still be getting credit for audibility up there, right? So even though the target is slightly below threshold, fitting to it would still give some speech peak audibility that would actually improve your SII value. The reason that it's below threshold is that you're hitting things like the compression threshold that's built into the target. We can't make all things audible. We do try to make the speech peaks audible even when the long-term average speech spectrum target is slightly below threshold. And I think that's probably what you sometimes get asked about.
Yes, exactly. Okay. So, and another question that people, 100% is not that what you are looking for. You are not going to get 100%.
No, you're not.
And you show the table that we could use to calculate, but it might be a different table for adults and children, as children need more information than adults does, right?
Yeah, so adults and children tend to wear different levels of gain and output in their hearing aids. For example, within the DSL-5 target, we have a higher level target for children than we do for adults. And so the norms that I showed you here, these norms that are here, these are for pediatric hearing aid fittings specifically. Adult fittings I would expect to have a lower SII value because the adults are wearing less gain and output in their hearing aids. A different normative table would need to be developed for adults if we were going to do something like this for them.
Yeah.
We did develop this as a pediatric tool for use in a particular EDI program. So that's why, but it certainly would be possible to make something like this for adults. I'm not aware that that exists at this time.
And then there's a question: does the SII have any relevance to speech and noise tests?
The SII certainly could have relevance to speech and noise tests. The standard does allow you to pull a masking noise into the SII calculations. As it is currently implemented in hearing aid fitting systems now, it's usually for an SII for speech and quiet. So it just doesn't, at this point, yet speak to speech and noise, but in the research literature, people often compute SIIs for their speech and noise stimuli that they're using in a research study. It's possible to do that. It is a little bit tricky to get the noise spectrum separated out from the speech spectrum from a hearing aid measurement. We certainly have worked with doing that using lab equipment, and it's harder than maybe you might think. It can be done, but it can be a bit tricky as well. So I think there's reasons why we don't see that in our clinical systems yet. I think it probably is on the radar screen for people to work on, but that would be a nice tool to add to the toolbox for sure.
And another question. You did the measurement of the SII of this case, you putting the probe microphone direct to the microphone. What is the difference of doing this measurement and do the calculation in the counted dots?
Okay, that's a great question. So if you do the unaided version of this, so where I did this trick where you're just measuring the unaided speech to get the 24%, anytime I've done this and compared it to the count the dots, I've gotten really close values between the two. Okay. So unaided, I think you can have a nice close agreement between the count the dots SII tool from the updated one and this. Aided, though, the only thing you have on the count the dots is the unaided thresholds. You don't have the hearing aid measurement, and you've got a sophisticated digital hearing aid that's got compression and everything else. And I believe that it's a better, I think that if you look at the literature on this, a fair statement is that a better way to get the SII value for a nonlinear hearing aid is to do it from a hearing aid measurement like this, because this takes into account everything about the hearing aid's compression and the level of speech that was used to stimulate that hearing aid. If you try to do the count the dots off of aided sound field, pure tone thresholds, warble tone thresholds, or whatever, it doesn't know anything about what the compression of the hearing aid is or what level or how that interacts with the level of the speech. It's a very, very low level threshold. It's a threshold for very soft sounds. It's not necessarily going to reflect what the hearing aid's functioning is looking like for 65 dB speech or 75 dB speech. We can measure that directly using a verification system, and it's an accurate way to do that. So personally, I don't use the count the dots tool with aided SII. If I want an aided SII, I get that out of my hearing aid analyzer. It's just a far more accurate choice.
Another question, what about frequency compression? Does SII take into account what frequency compression is doing?
In the SII, as it's implemented in clinical hearing aid analyzers, does not take into account the frequency lowering. It would need to know a whole bunch of details about the frequency lowering settings so that it could adjust like the band importance function, so that the importance that would have been associated with the high frequencies moves down into the wherever the destination or the compression region is of the frequency lowering system. We've certainly played with doing that offline in lab equipment, and it's interesting. It doesn't change the SII quite as much as you'd think. I've seen the group at Boys Town National Research Hospital and Iowa use an external calculation tool to make some corrections for that. And there's a few software tools from those guys that can allow you to try to automate some of that. Again, I think that would be a nice addition, but it would require a really detailed link between the hearing aid settings and the hearing aid verification. So essentially the verification system would need to know exact detail about the frequency lowering settings in order to make an appropriate set of corrections. So there'd need to be a really active link between those two systems to make that work.
Do you see an upgrade of the SII in terms of taking into account more the high frequencies? Because I would assume that even though it took into account the frequency lowering, because it doesn't take too much into account the high frequency, it wouldn't make that such a large difference.
That's exactly right. So the even if you pulled in the importance that exists in the high frequencies, it's so little that it doesn't actually change the SII very much, whether you do or don't account for that. So because there's not much importance there to have, so you can you could fix that by getting away from having importance functions and just leaving it as a raw audibility index, perhaps. It's one of the reasons why we like to pay attention to the bandwidth of the fitting and the SII. So we actually just look at both of those things. So I've got this SII, what's my overall bandwidth of fitting, and trying to maximize the bandwidth of speech audibility for every fitting that we provide, because it improves sound quality and it provides access to those to little sounds that maybe don't show up in the band importance functions of SIIs but are nonetheless important. So I think there's really two things to pay attention to.
Okay, I think we haven't got, sorry, perhaps there is, yeah, one more. Is there a low SII score like in the example you show? How does frequency compression or transposition help, and should, you have already, and should we change this? You have already answered that. Do you have any?
Yeah, I wouldn't adjust the frequency compression based on the SII value per se. I would look at bandwidth tools, and there are frequency-specific speech sounds that we can use to make measurements that tell us more about frequency lowering and how it's been fitted. There's also the maximum audible output frequency and some online tools from Josh Alexander's lab. If you have a look at those, they can sometimes be helpful as well. So there's really more bandwidth-driven tools that we can make use of for frequency lowering, transposition, or compression, and the SII doesn't really speak to that in a sensitive way.
Okay. Susan, I think I would say thank you for today. It was really great to have your speech. I have personally a lot of questions, always receive a lot of questions about SII, so that's why it was my idea to have you here, and I think you answer a lot of those. So thank you very much for being here today, and for those of you who has been participating, some of you think it was too fast, the speaker. As I told you in the beginning, we have record, so you have the chance to listen to it again if you need that for more clarification. And if you have any questions afterwards, you can write to me, and I will try to reply or ask Susan to help us with your questions. Thank you for everybody for participating. Thank you, Susan.
Thank you.